Hello everyone, my name is Ahmad Nandayuma Rafi and my friend is Octavia Niki. Here we want to explain about the introduction to artificial intelligence. It is about the search algorithm in artificial intelligence. Okay, let's start. In this presentation, there are five algorithms that we want to explain. But me myself, I will explain about hill climbing algorithm, breadth first search algorithm, and a star algorithm. And for the depth first search and the greedy algorithm will explain by my friends Octavia Niki. Okay, let's get the ball rolling. The first is hill climbing, the application of improved hill climb search algorithm in wind power generation. This is the title of the paper that we want to explain. For the introduction, in recent years, the development and utilization of renewable energy source, especially wind power, has become the focus of world's energy development, and there are a lot of MPPT methods such as ratio or TSR control, power signal feedback or PSF, Heil climb search HCS, and etc. These methods can achieve maximum power point tracking and thus make the system achieve the optimal output and improve the efficiency of power generation. In order to solve this problem, some new improved high claim search methods have been explored. In this paper, the author wants to explore the new high claim search. For the theory and or concept and method, the basic idea of improved high claim search is to choose the gradient direction of objective function as the direction of the iterative step size to approximate the maximum power point. Hence, the iterative formula of the improved high climbing algorithm can be written as following by in below, which is omega n plus 1 is equal to omega n plus a n g n omega. And using the optimal gradient method to search MPP, the advantage of the traditional method is kept, and at the same time, the convergence speed is changed because a variable step size replaces the constant one. If the rotate speed is far apart from maximum power point, the rotate speed changes a longer step, and the step length is shortened automatically as it close to the maximum power point. And the result and the conclusion. For the result, the simultaneous results show that the improved Halclim search algorithm has better anti-interference and faster convergence compared to the traditional one. For the conclusion is the speed approaching to the MPP is much faster with the change of wind velocity. So the new algorithm can better meet the requirements of modern wind generator system. The contradiction between rapidity and convergence is fundamentally solved in the fixed step hill climbing algorithm. For the next is paper about the breadth first search, with the title is Parallel Breadth First Search on Distributed Memory Systems. For, for the introduction, data-intensive graph-based computations are pervasive in several scientific applications and are known to be quite challenging to implement on distributed memory system. In this work, they explore the design space of parallel algorithm for breadth first search or BFS, a key subroutine in several graph algorithm, and they present two highly tuned parallel approach for BFS on large parallel system, a level synchronous strategy that relies on a simple vertex-based partitioning of the graph and a two-dimensional sparse matrix partitioning-based approach that that mitigates parallel communication overhead. For the theory and concept and method, for the first option is to use a priority queue of size NNZ or phi and perform a unbalanced multiple way merging. While this option has the advantage of being memory efficient and automatically creating a sorted output, and the extra logarithmic factor hurts the performance at small concurrences. Even after using a highly optimized change efficient heap, the cumulative requirement for these heaps are 0 m. And the second option is to use a sparse accumulator which is composed of a dense vector of values, a bit mass representing the occupied flex, and a list that keeps the indices of existing elements in the output vector. Then the result and the conclusion from this paper is the novel hybrid two-dimensional algorithm reduces communication times by up to a factor of 3.5 relative to a common vertex-based approach. And for instance, for a 40,000 core parallel execution on Hopper, an AMD Magni course-based system, we achieve a BFS performance rate of 17.8 billion edge visits per second on an undirected graph of 4.3 billion vertices and 68.7 billion edges with skewed degree distribution. And the conclusion, the experimental study encompasses performance analysis on several large-scale synthetic random graphs that are also used in the recently announced Graph 500 benchmark. The contradiction between rapidity and convergence is fundamentally solved in the fixed-step Hall-Clemming algorithm. The improved algorithm will be proposed for its practical significance in the research of maximum energy capture achieved. And the next is the ASTAR algorithm. An ASTAR algorithm for semi-optimization of crane location and configuration in modular construction, which is the title of the paper. So basically, this paper will explain about how the ASTAR algorithm for semi-optimization of crane location and configuration in modular construction. So this is the introduction. The use of heavy mobile cranes in one-set construction of industrial projects has become inevitable due to the high rental cost of such cranes. An optimized plan is essential for the multiple crane lift, and this plan reduces the operating costs of the crane by minimizing waste time and lessens the potential of failures and accidents. However, developing an efficient lift plan can be challenging and time consuming, considering the large number of lift options. In this article presents a novel framework based on informed search algorithm called ASTAR, which provides a semi-optimum lift plan based on predetermined lifting sequence. And as you can see, there is a theory and concept and method in this paper. For the relocation impact factor, as you can see, the formula is like this. And for the RF or relocation factor, it's like this. And this is the example of from this paper to calculate the relocation factor and the W, which is the life cost, and the rank, which is the summary of W plus RF. And this is the example. And then for the result and conclusion, the result, the proposed framework is applied successfully and validated in an actual modular construction project in Alberta, Canada. The results show a significant reduction in the total cost compared with the previously used lift planning algorithm. And the conclusion, the available safe lift options are provided based on the previously developed automated lift planning system called ACPO. The ACPO generates class free lift options and blocking precedence relationship, and the objective of the proposed optimization engine is to minimize the total cost of non-value added supporting tasks by selecting the lift option properly. And the cost and duration of the resulted lift plan were compared to the ASICO results. The comparison shows a significant reduction in the total cost and the amount of supporting tasks. It can be concluded that the proposed methodology can help project managers to provide an efficient module installation plan by automating its complicated process. For the next, my friends Nikki will explain about the next algorithm.
So, hello, I'm Octavian Niki Alpento. Like my friend said, I will continue from the explanation here. So, it's for greedy algorithms. For the title is Implementation of the greedy algorithm to determine the nearest route search in distributing food production. For the introduction, nowadays many companies produce foodstuff, foodstuff, but one of the major problems faced by the companies are the delay in distributing food production. It is found that the common difficulty faced by the food production companies in distributing the product due to long traveling distance, traffic congestion, natural disaster, and ambiguous route as well as unstructured routes. To overcome the problems, a greedy algorithm is implemented. The algorithm is able to identify the optimal pathway and time consumption by finding the closest distance, followed by the utmost distance. Therefore, this will reduce the cost of distribution and other company resources. For the theory, concept, and method, the principle of the greedy algorithm is to check every opportunity that exists at the moment without regard to the future consequence. The greedy algorithms form a solution from step by step, and at every step should be made the best decision in determining the choice. At this step of the algorithm, greedy takes the best option that can be gained at the moment without regard to future consequence. In this research, will be conducted analysis on the search of product distribution route through 5 distributors and 10 agents with attention to distance and duration of intercity travel so that distribution time can be utilized efficiently. Next. And for the result and conclusion, the result of this study show that the algorithm identifies route 5 as the best route. This because it will go through 5 cities, namely A, B, C, F, G, H, with distance of 648 kilometers. Although it's considered a long traveling distance, on the other hand, the algorithm suggests that 648 kilometers is the optimum distance to traveling to city H. And for a conclusion is the use of the greedy algorithm in the process of distributing food production obtained very good results. Rather distance to distribute foods from the city of A to H is only 648 kilometers and passing through 5 cities only. There are still two cities that are passed by, yet a greedy algorithm is able to decide that the 2 cities are not worth passing. And the next topic is depth first search, with the title A Work Efficient Algorithm for Parallel and Ordered Depth First Search. And for the introduction, advances in processing power and memory technology have made multi-core computers an important platform for high performance graph search or graph traversal algorithms. Since the introduction of multi-core, much progress has been made to improve parallel breadth first search. However, less attention has been given to algorithms for unordered or loosely ordered traversal. We prove that the algorithm is work efficient in realistic algorithmic model that account for important scheduling costs. This work efficiency result applies to all graphs, including those with high diameter and high out degree varieties. The algorithmic technique behind this result include a new data structure for representing the frontier of varieties in depth first search, a new amortization technique for controlling axis parallelisms, and an adaptation of the lazy splitting technique to depth first search. And for the theory, concept, and method, in this paper, we present a probably work-efficient and highly parallel algorithm for performing PDFS. The three key techniques behind the algorithm are a novel data structure called splittable by frontier and data structure for representing the frontiers. A novel amortization technique for controlling granularity of parallelisms and an adaptation lazy splitting to the unordered parallel DFS problem. Next. And for the result and conclusion, the result is we validate the theoretical result with an implementation and experiments. The experiment shows that the algorithm performs well on range of graphs and that it can lead to significant improvement over comparable algorithm. And for the conclusion, the technique behind the algorithm include bounding the overhead of scheduling such as thread creation and load balancing by amortization and by using a novel data structure for representing frontier sets. The data structure enables fast operation at both the level of vertex and edge by using a hierarchical representation and support balance split operation to create parallelisms as needed. Our empirical evaluation shows that the algorithm performs well for a wide range of graphs, including graphs with high diameter and graphs with relatively little parallelisms. The algorithm is also able to take advantage of the natural locality in certain graph layouts. Done.
Okay, thank you for all of you that have seen this presentation. My name is Ahmad Anda Yumarafi and my friend is Octavianiki, and see you next time.